Hi, today we're looking at Pearson Edexcel Functional Skills Maths Level 1. We're looking at past paper 7 and we're going to start with the non-calculator section. Question 1. Chen is a weather presenter on TV. The map shows the temperatures in 5 cities at noon on Monday. The temperatures are all shown in degrees Celsius. Chen says the range of these temperatures at noon on Monday is 8 degrees Celsius. So we've got the different temperatures here. Is Chen correct? Show why you think this. Okay, so Chen says the range of these temperatures at noon on Monday is 8 degrees. So we're interested in the range. And the range is calculated as the biggest minus the smallest. So which is the biggest number of these? Well, we've got 0, minus 3, 3, 0 and 4. Well, 4 is bigger than any of the others. So that's going to be 4. And it's minus. And what's the smallest? Well, we've got zeros. But smaller than 0 would be a negative number. So minus 3 is the smallest of all of these. Now, we don't want to be confused and think we've already used the minus. This is a takeaway minus. So then we've got minus 3. Okay, so minus is the operation, which we already had. And then the minus 3 is actually showing that it's a negative number. Now, hopefully you remember that when you've got two minuses together, that becomes a plus. So we've got 4 plus 3, which is, in fact, 7. And Chen says that the range is 8 degrees. Well, 7 is not equal to 8. So is Chen correct? No, he's not. And then we've got part B to this question, which is use a reverse calculation to show a check for your answer. Well, a reverse calculation means starting with the answer. And the answer in this case was the 7. If we bring this back down, you'll see this is what we calculated. We did 4 minus minus 3, or 4 plus 3, which gave us 7. So if we're doing it in reverse, we're saying 7, and we added on the 3 to the 4, so we want the opposite of that, which would be taking away the 3, which takes us back to the 4 that we started with, so that's fine as a check. Okay. Now we're on to question 2. Paulo invests £2,000 for 7 years. His investment earns 5% simple interest per year. Work out the total amount of interest the investment earns in the 7 years. Well, simple interest means the amount of interest stays the same every year. So if it's 5%, we want to work out 5% of £2,000. Okay, that's going to be our starting point. Well, 5%, if you want to work out 5%, you could do 5 over 100 and then times it by 2,000, which is fine. But instead what I'm going to say is, well, I'm not sure about 5% just yet, but I know if I want 10% of 2,000, all I need to do is take a 0 off. So it's going to be £200. Well, if I want 5% of £2,000, well, 5% is half of 10%. So all I need to do is half of 200. So I could use the bus stop method, but I know that half of 200, I know half of 2 is 1, so half of 200 is just going to be £100. Now, it's for 7 years. So we said with simple interest, the amount of interest stays the same. So if it's 7 years, we just multiply the 100 by 7. So 7 times 0 is 0, 7 times 0 is 0, and 7 times 1 is 7. And that's our answer. Question 3. the probability of an event happening is 7 over 10, or 7/10. Which of these words best describes the likelihood of this event happening? Okay, so we've got impossible, unlikely, evens, likely, or certain. Well, impossible, for it to be impossible, it would have to be a probability of 0. And it's not, so we can forget about that one. Let's try some of the extremes. The opposite to impossible would be certain. The only way we can be certain of it happening is if the probability is 1, or like 10 out of 10. So it's definitely not certain. Now, for evens, it means we've got the same probability of it happening as not happening. Or in other words, 50%, or in this case, half of 10, which would be 5/10. So it's not evens. So then we say, well, if it's not impossible and certain, and it's not evens, it's either unlikely or likely. And the important bit is about the sort of the evens, the halfway between. So halfway in the middle would be 5/10. Anything less than 5/10 would be unlikely. This is more than 5/10, so it's likely. We've got here are 4 numbers. Calculate the mean of the 4 numbers. Well, the mean is the total divided by how many? Okay, so let's do a total. Let's do it in the margin. So we've got 714, 720, 726, and 724. And we're going to add these all together. 4 plus 0 is 4, plus 6 is 10, plus 4 is 14. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus the carried one is 8. 7 plus 7 is 14, plus another 7 is 21, plus another 7 is 28. So we've got 2,884. Okay, well, we need to divide it by how many? So what we want is 2,884 divided by 4, because we've got 4 numbers. So if we do this with the bus stop method, we can do 4 into 2,884. So how many times does 4 go into 2? Well, 4 doesn't go into 2, because 4 is bigger than 2. So we say, all right, well, let's carry the 2 over and let's say how many times does 4 go into 28? Well, we've got 4, 8, 12, 16, 20, 24, 28. So that's 7 times. How many times does 4 go into 8? Well, we got 2, 4. Sorry, not 2, 4. 4, 8. So that's twice. How many times does 4 go into 4? Well, that's once. So the mean is 721. And we've got question 4. Harry sells bags of pasta. A bag holds 3 kilograms of pasta. Harry decides to sell pasta in boxes. A box holds 20% more pasta than a bag. A customer buys 10 boxes of pasta. How many kilograms of pasta does the customer buy? Right, okay, so the customer's buying 10 boxes. So first of all, we need to work out how much pasta one box holds. Well, we know a box holds 20% more than a bag. Well, a bag is 3 kilograms. So this is 3 kilograms. Now, if we're going to be working out percentages of it, then it's probably going to be easier if we convert that into grams first of all. And I know there's 1,000 grams in a kilogram, so that's going to be 3,000 grams. Okay, because otherwise I'm going to end up with decimals, and I'd rather avoid decimals if possible. Keep it simple. So we want to work out what 20% is so that we can increase this number by 20%, because a box holds 20% more than a bag. Well, 10% of 3,000, this is similar to something we did before. We just take a 0 off. It's going to be 300. So if we want 20%, well, 20 is double 10. So it's going to be 2 lots of 300. Well, let's work that out over here. 2 zeros are still 0. Same again. And 2 times 3 is 6. So we know that if 10% is 300, 20% is double, which is going to be 600 grams. Now it holds 20% more. So the box is going to hold the original 3,000 plus the extra 20%, which is the 600. So 0 plus 0 is 0. Same again. 0 plus 6 is 6. And 3 plus nothing is 3. So a box holds 3,600 grams. Okay. Now, we want 10 boxes. Well, I could do it as a column and do 3,600 times 10. But I know that if you're multiplying by 10, all you're doing is putting an extra 0 on the end. And then 1, 2, 3. So we've got 36,000 grams. They said how many kilograms? Well, so that means we need to divide that by 1,000 to get it back into kilograms. Well, if we cancel a 0 there with one there, and another with another, and another with another, we end up with 36 kilograms. So you could have done this by staying in kilograms all the time, but as I say, you'd end up with decimals. I think this is a simpler way to do it. And that's the end of the non-calculator section. Okay, so now we're on to the calculator section. Okay. Jenny has a decorative box business. She has a box in the shape of a cuboid. And the cuboid's 210 millimeters long and 148 millimeters wide. And we can see that on the diagram here. Jenny is going to glue one piece of ribbon around all 4 side faces of the box. So the ribbon's going along here, back, across, back down. The ribbon will not overlap. Okay, so it's a perfect fit. Jenny thinks a 72 centimetre piece of ribbon will be long enough. Is Jenny correct? So in other words, we want to know what's the distance all the way around here. Okay, well, what we can do with this one thing to notice is that the measurements given on here are in millimetres, but the ribbon is given in centimetres. So you can choose, we need to work out the distance all the way around here. Which way should we do? I'm going to do the conversion. I always say it's good to convert first. So if we want to go from millimetres to centimetres, well, there's 10 millimetres in 1 centimetre. So we're going to need to divide by 10. If you can't remember whether you need to divide or multiply, I think, well, if we've got millimetres, if we're going to centimetres, centimetres are bigger, so we're going to have fewer of them. So we're dividing by 10, so we're basically going to cancel out the 0. So we've got 21 centimetres. Now here, we're going to do the same again. We want to divide by 10 again to get to centimetres. Now we haven't got a 0 to cross off, so instead we think of where our decimal point is. It's like an invisible one at the end, 148.0. We're dividing by 10, so we're going to move that decimal point once over there. So we get 14.8 centimetres. So the distance all the way around is going to be 14.8 that way, plus 21 that way, plus another 14.8 going across, and then another. So actually, let's just sort of draw. If we sort of imagine we've got this ribbon going all the way along. So this is going to be another 14.8 there. And 21 up there. So 14.8 plus 21 plus 14.8 plus another 21. And we can use our calculator. And we get 71.6 centimetres. Jenny thinks a 72 centimetre piece will be long enough. Well, 72 is more than 71.6. So yes, Jenny is correct. Okay. If you wanted to, you could stick with millimetres, and what you could do is you could multiply this by 10 to get this in millimetres as well, and then you'd compare that way. Either way is absolutely fine. What you don't want to do is be comparing one distance in millimetres with one in centimetres. Question 2. A bag contains 26 counters. 5 of the counters are green. The remainder of the counters are orange. One counter is chosen at random. Work out the probability the counter is orange. Well, we've got 26 in total, so that's going to be our denominator. So how many are orange? Well, we've got 26 in total. 5 are green, so if we take 5 away from 26, I'm sure you don't need a calculator for that one, but you can use it anyway to check. We get 21 over 26. Okay. Now we've got here is a drawing of a kite. Draw the line of symmetry on the kite. Well, the line of symmetry is the line that splits the shape exactly in half with a mirror image of itself. So for this one, you can imagine if we folded this down the middle, that would match perfectly onto this side. So we find the corners, and with the line of symmetry, I like to draw it all the way through the shape. You don't need to do it just on the shape, have it passing all the way through. Okay. It doesn't matter if you do it just on the shape, I just think it's clearer to do it passing through it as well. And then we've got part C. Measure and write down the size of the reflex angle X. So they want us to measure this angle. Well, if we're measuring angles, we use our protractor. Now, my protractor only goes up to 180 degrees. And I can see that this is more than 180 degrees. So what I'm going to do instead, I'm going to measure the angle inside. Okay, and you'll see, if I put my crosshairs right on the corner, that it's lining up. Look, I have to move it because it matches so perfectly. It's lining right up with this 60 degrees. Because we're starting here, so 10, 20, 30, 40, 50, 60, where it meets it. So this is 60 degrees, but we want the reflex, the angle on the outside. Well, I know the total degrees in a circle are 360. So if I take away this acute angle here, it's going to leave me with the angle on the outside. So we can use a calculator, but you can also see if it's 360, take away 60, we're just going to be left with 300 degrees. Then we can put that down there. Now, one other way of doing it, if you wanted to, instead of measuring that angle, you could extend this line along here and say, well, I know this bit is 180 degrees. So if I measure this angle in here, so now I'm measuring from the left because I want this angle inside. So 0, 10, 20, 30, 40, and I'd go all the way around to this line here, which is 120. So that would be this bit inside. So then I'd add up 180 with 120, and we would get exactly the same answer. Okay, so this is just an alternative. So that's just an or if you want to do it that way. Again, more than one way, both give the correct answer, absolutely fine, whichever way you choose. Question 3. Write down 3,257 in figures. So 3,000. So use the 1,000. We know that we have a comma for the 1,000. So 3,000. 1,000, and then 257. 257. In fact, we can write it in here. It's always good to write it down first just to check you're happy with it before you put it in the final answer box. Now we've got write the number 1,024 in words. So we've got no hundreds, so it's just, I always like to put the comma in, so it's 1,000. And we've got no hundreds, so it's just 1,000. And 24. Okay, now we've got another part to this question. We've got Ella works in a post room. She has these parcels to post. Here are the exact weights of the parcels. Okay, so we've got lots of different weights here. Ella uses a frequency table to sort the parcels into 3 groups by weight to work out the cost of postage. Complete the frequency table for Ella. Okay, let's move it up so we can see everything there. Yeah? So we want to know how many we've got that are between 0 and 2 kilograms, between 3 and 20 kilograms, and between 21 and 30 kilograms. Right, so we can start to count them up. But before we do that, we've got some weights in here that are in grams. So I'm going to convert these into kilograms before we start, so that then we've got everything in the same units. Always good to do the conversions. And we know that we've got 1,000 grams in 1 kilogram. So if we've got 3,000 grams, that's going to be 3 kilograms. Okay, these are all in kilograms, that's fine. So 6,000 grams is going to be 6 kilograms. All in kilograms, kilogram. So 21,000 grams is going to be 21 kilograms. If you want to, you can use your calculator and do 21,000 divided by 1,000, and you're going to end up with 21 kilograms. Right, so now we need to put them in the frequency table. So you can go one at a time and then mark them off as you go, but I'm going to do it a different way. I'm going to say, well, how many are between 0 and 2? That's more. There's one. There's another one. And there's another one, so that's 3. And those are all bigger. Okay, so we've got 1, 2, 3. 3. How many are between 3 and 20 kilograms? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in fact I'm sort of cheating because I'm doing the tally afterwards. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And one more to get the 11. And then how many in 21 to 30 kilograms? We've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, and you see I crossed them off as I went, so I didn't do any double counting. And if we want to check as well, we can say we've got 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 times 5 is 20. So if we add these all up, 3 plus 11 plus 6, we should get 20 as well. Yeah, so we've got the right amount there. Question 4. A robot is programmed to move around a grid. The direction of north is shown on the grid. That's on here. The robot can move forward and can turn. The robot follows this set of instructions. I'm going to move it up so we can see our robot there as well. Okay, so we're going to start. And then the first step, it says move 50 centimetres forward to position A. Then turn on a bearing of 270 degrees. And then move 60 centimetres forward to position B. On the grid, mark with a cross and label each of position A and position B. And there's something very important at the bottom of this grid, which says 1 square length on the grid represents 10 centimetres. And the robot start position facing direction of arrow. Okay, so he's looking up. So let's have this down here. So we're saying each of these is 10 centimetres. So if we're moving 50 centimetres, well, 50 divided by 10, we can use our calculator, gives us, so that's going to be 5 boxes it's moving. That's the P for boxes, not 56. Then it's going to turn, and then it's going to move 60 centimetres. Well, how many boxes is that going to be? Well, 60 divided by 10. You can probably work it out, but let's use the calculator. So that's going to be 6 boxes. Right, so if we're starting here, we're going to move 6 boxes. So that's 1, 2, 3, sorry, we're going to start off by moving 5 boxes, aren't we? 1, 2, 3, 4, 5. They want to mark it with a cross, and that's point A. Okay. So I'm going to draw where he's moved as well. Okay, they haven't said we have to do that, but I'm going to mark it on. Right, then it's going to turn on a bearing of 270 degrees. Right, well, if we think 270 degrees, well, I know 180 degrees would take me all the way around to here. Okay, that's 180 degrees. And I also know, well, if we want 270, what we can do is say, well, what's 270 minus 180? Well, that leaves us with 90 degrees, which is a right angle. So if we've covered that distance, we'd need another bit. So that would be 90 degrees there. So all the way around would be 270 degrees. Okay, now we've already moved up to point A. So a bearing of 270 degrees. So we always start with north, measure 270 degrees round, which we've seen on here, means that we're going to go all the way around to here. Okay, so this is 270 degrees. So it's now going to be pointing that way, to the left or to the west. And now we need to move 6 boxes. So 1, 2, 3, 4, 5, 6. And I'm going to draw my line. Again, it hasn't asked us to draw the line, it just wants the cross. But I'm doing it so you can see how we've got there. And then we just label it with a V. Okay. Question 5. A cube has side length 20 centimetres. Calculate the volume of the cube. State the units in your answer. Well, the volume is the length times the width times the height. In other words, it's the 3 dimensions. So this way, and this way. And because it's a cube, all of these measurements are going to be the same. So it's 20 times 20 times 20. Okay. Now, I'll do it with a calculator, but actually I'll show you how we can do it without. We can ignore the zeros, so we can say 2 times 2 is 4. 4 times 2 is 8. And then we just put the 3 zeros on. Okay, but I'll show you that that is correct. Okay, so nothing wrong with using a calculator, just showing how you can check it as you're going. And it's centimetres, but because it's been multiplied together 3 times, it's centimetres cubed for volume. Question 6. Grace looks at her electricity bill for November. So I've got electricity bill. We've got the meter reading last time, 20,312. kilowatt hours. So I'm going to put a comma in there. And meter reading this time is 22,198 kilowatt hours. The unit cost is 5.4 pence per kilowatt hour used. Now, if you don't know that kWh stands for kilowatt hour, it doesn't matter. Yeah, it's just a unit. The standing charge is 30 days at 16.74 pence per day. And we've got total bill for November of £105.84p. Grace knows the meter readings are correct. Okay, so that's these two. Is the total amount on the bill for November correct? You must show you're working. Right. Well, first of all, we've got the standing charge. So even if you had used no electricity, you'd still have to pay the standing charge. So we've got 30 days at 16.74p. So if we multiply those together, we get 502.2. Now that is pence. We've got to remember that it's p. So if we want to turn it into pounds, we're going to divide it by 100 because there's 100p in a pound. So that's £5. And with pence, you only have two decimal places. So 0, 2, this is less than 5. So we just keep it as £5 and 2 pence. Right, so that's the standing charge. Then we've got the actual use of the electricity. And we've got a unit cost of 5.4 pence. So we want to know how many units have been used. So in other words, we want the 21,198. So the meter reading this time minus the meter reading last time. So we can see what it's gone up by. Okay, so 22,198 minus the 2312. And we get 1,886. So that's going to be kWh. Okay, if it's 5.4 pence, we want to multiply that by 5.4. And we get 10,184.4p. Now, if we want to turn that into pounds, we divide it by 100. So we're going to get 101 point, and we want two decimal places, so 84. This is less than 5, so we can ignore it and just keep it as 84. So a little bit of a scribble there going off the page, but basically we've got the unit, the unit cost kind of amount is £101.84, and then we've got to add on the standing charge of £5 and 2p. So if we add these together, we end up with £106.86. Okay. Well, they've said, is the total amount on the bill correct? Well, £106.86 is clearly not the same as £105.84. So is the total correct? No. It is not correct. If anything, they're undercharging, so you could say it doesn't matter, you're saving £1. But you probably should be paying the correct bill. Okay, question 7. The diagram shows a triangle. The triangle has base length 34 centimetres, that's here, and height 22 centimetres going up. Put P on the triangle, point P on the triangle is directly above the middle of the base. Okay, so that's halfway along here, okay? And they said, draw a scale diagram of the triangle on the grid below. Okay, well, if we're going to draw, and we've got a scale here as well, we're told that 1 square length on the grid represents 2 centimetres on the triangle. So we can say that this is 2 centimetres. Right, so we've got this measurement, we've got this measurement. What we don't know is how far along this P needs to be. So what we kind of want is this distance, really. Well, they've told us that P is halfway along this line. So what we want to do is half of the 34. So if we do 34 divided by 2, that's telling us that this distance is 17 centimetres. Okay, so, right. So we've got 34 centimetres, 17 centimetres, 22 centimetres, which is great. If we're drawing it on this grid, all of these squares are 2 centimetres. So that means that we've got 34 centimetres, but we only want half as many boxes. So we're going to divide that by 2. In fact, we have already divided it by 2 for this calculation. So 34 centimetres is actually going to be equal to 17 boxes. If we do the same with the 22, if we divide that by 2, you'll see that we get 22 divided by 2 is going to be equal to 11 boxes. And if we do the same with the 17, let's do it over this side, so it's 17 centimetres, divide that by 2, so that's going to be 8.5 boxes. Right, so now let's start drawing down here. So we want our base to be 17 boxes. So I'm going to start in this corner, make sure we've got enough room. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, I'll use a ruler to draw my base. Okay. Right, now before we draw P, we want to know where halfway along this is. If you remember, we worked out that it was 8.5 boxes. So 1, 2, 3, 4, 5, 6, 7, 8.5 will be there. And it was 11 boxes high. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there you go. There's a scale drawing of our triangle. Question 8. 3 groups of students are going on a school trip together on a coach. Group A has 13 students, Group B has 17 students, and Group C has 20 students. There should be 1 adult for every 16 students on the coach. Work out the least number of adults that are needed on the coach for this school trip. Okay, so what we want to do is work out how many students we've got in total first of all. So 13 plus 17 plus 20. We can use our calculator. To give us 50, I've called them students rather than children, that's fine. We've got 16 on each coach, so we want to say, well, how many 16s fit into 50? Or 50 divided by 16. We get 3.125. Well, you can't have 0.125 of an adult. And if we just went with 3 adults, that wouldn't be enough. Because if we had 3, you can only have 16 for each one. That would only be enough for 48 students. So we're going to have to go with 4 adults. Question 9. Yolanda buys a coat online. The normal price of the coat is £205. Yolanda uses a 15% discount code. Work out the price of the coat after the discount. All right, so we're going to work out 15% first of all, and then take it away from the £205. So 15%, so 15 divided by 100 multiplied by the original amount. Okay, so 15 divided by 100, multiply it by 205, and we get £30.75. And it's a discount, so it's coming off, so we can subtract it from the 205. So we've already got that there. I'll put that in my memory and then say 205 minus the memory recall is £174.25, which we can write down there. Now we're asked to show a check of your answer. Right, you could do a reverse calculation. I'm going to do something a bit different. I'm going to say, well, if it's 15% off, you can think of it as 100 minus 15. So 100%. We take off 15%. That leaves us with 85%. So in other words, the price after the discount is 85% of the original. So we can do 85 divided by 100 times 205, which gives us £174.25 again, which is correct. Yeah, so you could do a reverse calculation as well if you want. I like doing it this way. I think it's really handy, especially if you move on to level 2 and GCSE later on. Okay. Question 10. Abby has a pet rabbit that weighs 5 kilograms. She buys packets of food for her rabbit. Abby has this information about the number of packets of food rabbits need each day. So you take the weight of the rabbit in kilograms, multiply it by 2.2, divide it by 2.75, and that gives you the number of packets per day. How many packets of food does her rabbit need each day? Well, so we said we'd take the weight, which is 5 kilograms, and multiply it by 2.2. So we're going to do one step at a time. So 5 times 2.2, that gives 11. Then we're going to do I'll do a new step. We're now doing the 11, and we're going to divide it by 2.75, which gives us 4, and that's the number of packets. Okay, then we've got the last question of the paper. Edward is writing an article about a sponsored race for charity. Edward knows 180 people are running in the race. A quarter of the people are running for pet charities. 2/9 of the people are running for health charities. The rest of the people are running for youth charities. Edward wants to know the number of people running for youth charities. Work out the number of people running for youth charities. Right, well, if we know the total, we can use this to work out how many are running for pet charities. We can use this 2/9 to work out the number of people running for health charities. And if we take these both off of the 180, what we're left with are the people running for the youth charities. Okay, so this one, what we want is 1/4 of, or 1/4 times, 180. Which is 45. Now for this one, we want 2/9 of 180. It's always of the original amount because it's 2/9 of the people, and the people are 180. Now, if we do 2 divided by 9 times 180, you'll see we get 39.99999, which we can easily round to 40. But if you want to avoid that, a good way to do it is to type the multiplication in the other way round. So do the 180 times 2 and then divide it by the 9. Takes you straight to the 40. Okay, so what we want to do is we want to add these two together. That gives us 85 people running for either pet charities or health charities. So those running for youth charities must be 180 minus the 85, the total of running for the other charities. So I can put that in my memory. Do 180 minus the memory leaves us with 95. Okay, so that's the end of the paper. So I hope you found it helpful. Please subscribe to the channel, like the video, give me any comments you've got, and I look forward to seeing you again soon. Thank you.